So first and foremost, I am going to grab my ball peen hammer. We do not need a very heavy hammer, and to be more specific, the 16-ounce hammer is going to be ideal because it will prevent us from applying too much force to these small components, bending or damaging anything. In addition to that, we need a tool to be able to, first and foremost, remove the dust cap off of this assembly. And so what I'm going to use for that is actually going to be a cold steel chisel. It is going to act as a wedge and separate out the distance between the rotor itself and the dust cap that is covering all of the grease and components behind it. So I will do so right now. Notice I am not striking very aggressively against this dust cap. It does not take an excessive amount of force, and I am just taking my time to rotate the assembly as I do so, walking the dust cap off of the component, just like that. So this is your dust cap. Notice there is nothing much to it. It is just a metal disc that has a hollow space and fits over the top of our components. Just think of it as keeping dust out. It's not necessarily sealing anything in. It just keeps our dry components away from our wet components. I have my magnet tray here, both for demonstration purposes, so you can keep track of the components. But in addition to that, I'm sure you are all very familiar with organization on the job. It is important, and it will improve your efficiency and help you not make mistakes or lose track of what you're doing. So I've used my ball peen hammer and my chisel to pull the dust cap off of my assembly, and now I have exposed a cotter pin, my locking washer, my tabbed washer, my spindle nut, and then in just a moment, you will actually see the heart of these components, which is the outboard and inboard wheel bearing. So let's move on to removing those components right now. So next step, I'm going to take my needle nose pliers. They will allow me to grab onto one end of this cotter pin, this non-threaded locking fastener, and I'm going to just bend the ends of said cotter pin straight up and down vertical so that I can grab the eyelet of this cotter pin and pull it straight out of the spindle. So this cotter pin is what prevents the components on the spindle from shaking or vibrating off of our vehicle, causing a very dangerous catastrophic failure during operation of an automobile. So I will set that on my magnet tray. Once your cotter pin is off, you should be able to just with hand pressure pull off your locking washer. The locking washer engages with that cotter pin as a part of that locking mechanism. So I will set that on my magnet tray and continue on to the next component to be removed, which is going to be my spindle nut. As I remove this spindle nut, I am paying attention to how much pressure it takes to break the initial tension between the nut and the rest of the assembly. If you noticed, it took barely anything. Now that is actually correct. If it takes more than the pressure your fingers can apply to further loosen the nut, it has been over-tightened by either a previous technician or from the factory that manufactured the vehicle. And so it taking very minimal pressure is good. It indicates that this wheel bearing assembly was properly adjusted the previous time. Now in this particular spindle nut, there is nothing special about it. It is your standard hexagonal nut with that is threaded on the internals and just threads right onto our spindle. So I will set my spindle nut onto my magnet tray and continue. Now that we have all of our fasteners removed from the spindle, I can actually just rock the entire hub integrated rotor back and forth. And as I did so, what fell away from the assembly was a washer that has a tab. This tab engages with the spindle itself. And then I have my outboard tapered roller bearing. Now this is one half of the heart of the component. You can see the rollers within the cage here, the inner race on the inside, which is just the structure and allows these rollers to roll. You can see the cage in between the rollers. And then in this case, our outer race, which the rollers race up against, is going to be pressed into this hub integrated rotor here. So my outboard tapered roller bearing is removed. I will set that on my magnet tray. And then I could just remove this entire hub integrated rotor off of the spindle right now. However, what we have left to disassemble is actually the backside of this hub integrated rotor. What is on the backside of this, or inboard to use industry terminology, is going to be this inboard tapered roller bearing, as well as the seal that seals in all of the greases. So we have a dust cap on the outboard side, and we have a wheel seal or oil seal or grease seal, all terms are correct, that seals in our grease, aka lubricant, for these bearings to maintain operation with minimal friction. So how do I remove that inboard taper roller bearing and our grease seal? Well, if you remember this hexagonal nut, we are actually going to thread this fastener onto the spindle until when I look at it from the side, the front-facing surface of the nut sits in parallel, not behind or in front of, but sits in parallel with the end of our spindle. And then I'm going to grab the rotor with both hands, and I'm going to pull down and towards me in one smooth motion, just like so. That removes that inboard taper roller bearing as well as the grease seal. And you can see the inboard race present, just like we had that race on the outside. So there's one on the inboard, one on the outboard, very standard for a hub with tapered roller bearings. The components that we successfully removed, here is that grease seal in more detail. And then here is the inboard tapered roller bearing. You notice it looks very, very similar construction, but it's larger. It's larger because it manages more of vehicle axial load and thrust. So the motions that this hub needs to manage is majoritively being applied to this inboard taper roller bearing. So I set that down and I set that down. And that would be the entire removal process for our hub integrated rotor and its components. So I know that's a lot to go over in just that short amount of time. Does anybody in the classroom or otherwise have questions on the removal process? Okay, can I get a quick thumbs up, sideways, or down on confidence using the tools and removing those components? Okay, I've got thumbs up from everybody, so I'm going to continue to the next part of our service. Let me just place this nut back so I don't lose track of it. The next part of our service that I will be demonstrating today is going to be packing our bearings with grease. So what you will need for packing your bearings with grease is, well, you need the bearings first and foremost, and you need some grease. So for the purposes of this demonstration, we are going to pretend that these are brand new bearings and all they need is some grease. But if you're going to be reusing your bearings, you need to clean and dry them first. But we're going to pretend that these are brand new. So we have our bearings and we have our grease. This is standard wheel bearing grease. You can get it from any automotive parts vendor in the Valley. But you got to make sure it's filled with wheel bearing grease and not other kind of chassis grease or, hopefully not any sort of very low viscosity oil that will not function, that will cause the bearings to burn themselves out. You need wheel bearing grease. So I have this tool here filled with wheel bearing grease, and then I'm going to have a packing zone, which I place the bearings onto, and then a press. And this press is going to apply pressure and allow grease to populate in between the rollers and the cage itself. So I'm going to take my, in this case, outboard tapered roller bearing, and I'm going to place it tapered down right into our tool. I grab the press. I like to grab a rag just to help me with the size of my hands versus the size of the tool. This helps me both not hurt my joints and maintain good grip. And you're going to need to put a good amount of pressure because wheel bearing grease is very high viscosity, and you just press down. You will know that you have done a good job when you begin to see grease eject itself in between that negative space of the rollers and the cage that houses said rollers. So pretty straightforward use of the tool. However, doing a proper and thorough job is where the skill and technique comes in. So now all you need to do once you've packed this bearing full of grease is make sure it rotates freely, so very close to zero friction in the rotation of this assembly. And you just make sure you didn't miss any spots. So you're visually checking around the exterior of this component and applying any grease to any spots you might have missed. And now I can just set that aside for reinstallation. So I'll real quick talk less, and I will just go through the grease packing of this other bearing real quick. Quick tip for making sure that your rollers spin freely is you need to grip the inner race of this assembly very tightly while you got grease on it, so it will be slippery. And if you don't hold on to that inner bearing race, then the whole cage will just kind of float on your hand, which will not allow the rollers to roll. So you need to isolate the roller in the cage by gripping that inner race pretty aggressively. So that is going to be the conclusion of packing the bearings. Before you move on to reinstalling all of your components onto the vehicle, you must remove your greased up gloves. You do not want any of this wheel bearing grease to be applied to our braking components. So if we have grease applied to our braking components and the pads try to clamp down, there will be a friction reducer, the grease, and we want friction when we're braking. That is what allows us to stop. And so keep these rotors clean. Remove those gloves before you move back to reinstalling all of your components. I'm going to shift us back over. I need to dismiss this notification so I can see that I'm pointed in the right direction. Right there. Okay. Now we are going to move on to the final part of this demonstration, which is the reinstallation process. But once again, is there any questions from the class on the grease packing or cleaning of those bearings specifically? Okie dokie. Well, we're going to move right along. I'm applying my new fresh set of gloves for reinstallation, and we are going to install the inboard bearing, the grease seal, and then we're going to put everything back onto our spindle. And I actually made a slight mistake. We're not pointing that way yet. What you are going to need now for equipment for replacing your inboard bearing is going to be a seal and race driver. So these are going to drive in that final seal that I demonstrated to you all earlier, which will allow us to keep the grease within the assembly and not have it escape, which could lead to the complete destruction of our wheel bearings without exaggeration. So it is very important that we remember our grease seal every time. So as we install, I'm just going to apply a little bit of extra lubricant to the inside of our hub, in this case, our hub integrated rotor. I'm going to collect my grease seal and my inboard bearing, and what I'm going to do is with the hat of the rotor facing down, I'm going to take the taper, and the taper just drops straight down. Easy as that. However, the next part takes a little bit more of technical skill. So this grease seal needs to be reapplied with this silicone lip facing downward. So I'm going to rest that on top of our tapered roller bearing. And then I'm going to take my seal driver and I'm going to find a disc that matches the size of our seal, which first try, that is the driver that matches the shape of our seal. It is very important during seal driving that you drive the seal parallel to the surface of this hub. You don't want to drive a seal in diagonal or walk it around. You can either damage it or unknowingly damage it, think it's okay, and cause it to leak grease later. So once again, I'm just going to grab that ball peen hammer, coming right back to it. I am leveling out my driver and my seal to make sure that it drives in straight. With one hand, I hold the driver. With the other hand, 3 strikes should be all that it takes. You'll hear a dull ping, ping, ping. And if you strike one more time, you'll hear a much higher pitched ringing, which indicates the driver has met with the hard cast iron of the hub, and you should no longer be striking the component. I remove my drivers. I set them back into my little toolkit here, and I will just keep it out of my way. So now you'll notice as we work backwards through this procedure that we now once again have our inboard tapered roller bearing and grease seal inputted into our hub. So this little hub here lives inside the bigger rotor. We're right back to reinstallation. So now at the correct moment, I am shifting us to our spindle once more. So taking our hub integrated rotor, I'm going to place it onto our spindle and then tying it back to our performance objective through my understanding of stacking the components, I can now correctly in sequence reconstruct this component. So what we will need is to collect all of the bearings, our washers, as well as our fasteners. So I will reintroduce these to you as I reinstall them onto the hub and spindle. First and foremost, you must grab this outboard bearing, the smaller bearing, if you remember, and I'm going to take, once again, the smaller tapered side. That smaller tapered side is going to go towards this hub. So I press it towards the hub and I leave it there. Next on the reinstallation list is going to be this tabbed washer. So this tabbed washer has been used several times and I can see some wear marks. I see wear marks that match the shape of our bearing race, and I see wear marks that match the shape of our hexagonal nut that spins down onto it. So I am going to reinstall it how I found it, because if you didn't know, wheel bearings, they do something called wear mating. So as they go through their service life, they actually match the positive and the negative shape of the components right next to it, and you must install them the same way as they go back on. If you do not, once again, as with all the other times, if you don't follow this procedure, is you will end up putting excessive pressure and friction and heat on the bearings, and they will fail. What it means, if they fail, they no longer roll. If they no longer roll, the vehicle can't move. So it is very important to follow that procedure. Next on our list is going to be the spindle nut. This is just a standard hexagonal nut. So I'm going to take it, place it on my spindle, and spin that down. Now, we have finally arrived at our preloading sequence. So what that means is I'm going to take my arc joint pliers. These arc joint pliers are going to sit on this nut, and I'm going to spin my hub and rotor assembly, and the goal of this preloading sequence is to remove any end play, in this case, call that lateral runout, in the hub integrated rotor assembly. So I'm going to continue spinning as I tighten this nut down. No pressure yet, so I keep spinning, keep tightening. And why we want to remove all of the lateral runout from this hub is that we need those races that I keep bringing up to be contacting the spindle constantly, allowing consistent rotation of our bearings. We don't want our bearings to behave differently over time. We want them to maintain a similar function. So how do I check if I've done the preload properly? You just take your hands at the top and bottom of your rotor and you just rocket your hands back and forth. If your hand pressure cannot create any shifting or clunking in the assembly, you have properly preloaded your assembly. In a future lesson, I will be going over how to make your final adjustments for this assembly. However, that is outside of the purview of this demonstration. So for now, I'm going to just back off the nut until I can twist it back and forth with my hands. And we are going to close out this demonstration. So next on the list is our locking washer. I place the locking washer on the nut. And now we must replace our cotter pin. Our cotter pin is a single-use fastener. So it locks down our assembly effectively. However, it can only be used a singular time. So what I need to do is locate a cotter pin that has the same diameter on each of these pins here that come away from the eyelet. However, the new pin should be longer than the original pin because this pin has been cut. And so I'm matching diameter and I'm looking for a longer pin. There we go. So to demonstrate my point is we have two eyelets here, and you'll notice on the other side of my finger, we have one cotter pin extending further, and this other one has been cut short. This longer pin allows me to properly install onto the spindle, and how it does so is the longer pin I drop through my spindle hole right here, and I actually grab onto the longer pin and I bend it up against this spindle. So I'm taking that long pin and I'm bending it against the face of this spindle, just like that. And you'll notice I cannot move this cotter pin. There is no way for the assembly to rotate or move in any way I don't want it to. Or is proper, I should say. Outside of my own wants, it's proper for this cotter pin to not shift up and down. So a couple of things left with this installation is, well, the cotter pin is kind of getting in the way of something. It's getting in the way of my dust cap. I don't want dust in my grease, so I need my dust cap. So I need to make room for my dust cap. How do I make room for my dust cap? Well, I am going to snip this cotter pin in line with my locking washer. Diagonal side cutters work fantastic for that. So with all of these components installed, the spindle and the hub, everything spins great. All I should have to do is install this dust cap. And I better have space for it because I just made space for it. How I reinstall the dust cap is very similar to the removal, is I just line it up parallel with my hub integrated rotor. I'm going to spin and tap on the edges of this dust cap. I will say that dust caps are probably the most damaged component in reinstallation. And the reason for that is because people take their big 32-ounce ball peen and they start swinging that hammer at the dust cap really aggressively. That is not necessary for proper reinstallation. So that is all the force that you need to install that dust cap. And just like that, we have fully removed our wheel bearings and hub assembly, grease packed the bearings, and fully reassembled and preloaded the entire assembly. Is there any questions now that I've covered the entire procedure from start to finish? Okay, and then one last time before I move on to some other discussion points. I want a thumbs up, sideways, or down on this entire procedure. Okay, I see some thumbs sideways, some thumbs up. That's pretty standard. And not to worry, we are going to have practice performing this task. So if you're not feeling very confident in your abilities or the procedure itself, there will be practice. I will continue to teach you as you run through it yourself. And that brings me to the lab assignments that we will be running through as a class in the laboratory environment. So I'm going to share my screen here. and we will discuss